I'm going to talk about this 5G edge computing, about how to bridge the gap between devices and the future. And I would like to share with you a little bit what is the view from the telecommunication side. So that's why we're going to talk a bit about this cloud edge and about also MEC. So these are like the main topics we're going to have today. Anyway, if you want, you can ask whatever question you want, and we will try to answer all of them at the end of the presentation. Can you see my slide, Mr. Richard?
Yeah, we can see your slide.
Okay,
and we can
okay,
hear
good.
you loud and clear.
Okay, good. So in general, when we have this telecommunication, we are working about these particular three components. We have like this mobile core. We have the radio parts, the radio access part, where we have for sure all of these Open RAN components or BTS, and we have these devices. We need this transport with a fiber, a satellite, microwave, or whatever solution of transmission we have. And also we have the spectrum available for the communication. So we have like these 5 components to make our wireless network available for all the users. Let me. So when we have like this network, we are having, or we have lived like this evolution of the network. We have like this evolution from the classical network appliance, where we have like this network function or dedicated hardware or physical network functions, where we have a particular hardware with a particular function. For example, like DPA, SGSN, and GGSN for the packet core. All of these components are related with the hardware. So you have one specific hardware built with one specific software. When we start with all of this evolution, we have to start having this virtualization, as we can see here. So we're using all the advantage of the technology to use like a general architecture to put a hypervisor and all of these virtual network functions over that hardware. So we can have like this generic hardware or these code hardwares with virtualization. And then what we are having of all of those components of core and radio access that we have before is the cloud native or the cloud virtualization of all of these components. So instead of having virtualization components as we have before, now we're talking about this main concept here called let me just call this container. So we're using this cloud native definition to put all of these functionalities, or this container with all of these functionalities that we can use for telecommunication, as we can see here. So we have like this evolution from the classical network appliance, where we have a specific hardware with a specific application, the virtualization or the network function virtualization. And right now, what we're experiencing right now is having all of those development for cloud native, in particular, to deploy telecommunication functionalities over the cloud. So in this cloud journey, so this is like another way to see like this evolution, where we have like this physical, where we have like particular hardware with particular software for each of the functions, the virtualization, the cloudification, and then the cloud native. So on this moment, we are here. I mean, we said that the cloud native, I mean, the cloud functions are available today. So most of the just like all the deployments we have right now with the 5G cores are already cloudified, either using a public cloud solution like AWS, or using like a private solution of cloud, like for example, from Red Hat or from any of those providers. And so the future that we are going to be like very soon is this cloud native. Cloud native in general means that we can move from one cloud to another cloud of all of, I mean, to change all of these functionalities from one cloud to the other cloud like very easily. Right now we can do it, but we need some work. I mean, to define or to deploy it, for example, in one on cloud from AWS or in a cloud from Red Hat or from Ericsson or from whatever provider. But it's expected that in the future, when we have like this cloud native usage or deployment, we can deploy all of our functionalities without caring so much about what is the cloud behind. So when we have like this edge, we can have like different interpretation of the edge. I like this graphic very much because shows you like how every provider is looking at the edge. For example, like the hyperscaler, they consider the cloud just on the main building, on the main central of the solution, and edge whatever behind that, the remote edge and the very edge. So we have like different. This is just to show you that we have different visions for the edge. And so in the next slide, I will show you like what is the definition from our telco So we have like these are like the main concept that we have for this ecosystem in telecommunication. We have this cloud computing that is a concept that we use also from IT and from telco side. It's a model that we have like services everywhere on demand, and we can share all of those resources, as Mr. Raymond has explained today, and also as he explained the last week. So we have like these resources available for our processing, and we can expand or we can be flexible to grow or decrease the size depending on what we need. On demand service available for all of us. Also, we have like this fog computing. I mean, FOG computing is another definition that we usually can see in some technical documents from IT. It's very similar to the edge. In the particular things for this fog computing is they have this additional layer for processing and potential data aggregation before moving to the cloud, as we will see in the next slide. Also, we have like this edge computing that is a concept used also for telco and also in the IT world, where there is a decentralized computing framework that brings computation and data storage closer to the location where the data is generated. Also, we have this concept of the multi-edge computing that is essentially an ETSI standard. It's essentially the same as the edge, but it's defined by the ETSI. In particular, it's a telco definition. The edge computing is a telco, and IT, this multi-access edge computing is telco definition. And also we have like a small concept called cloudlets. Today, I mean, we don't have like this in so many technical documents, but if you see technical documents from 2 or 3 years ago, you still can see this definition of cloudlets. The cloudlet is essentially a small scale data center or cluster, for example, for a small office located. So we have like this main concept: cloud computing, fog computing, edge computing, multi-access edge computing or MEC, and also the cloudlet. So today we're going to talk about our focus will be in particular for edge and multi-access edge computing. As we can see here, this is a very good drawing that I got from the Red Hat team, where you can see like the different components in a network, or how are deploying all of these components in a network from the core located here, or regional data center, for example, located in the capital, in our Manila city, main capital. Provider edge, maybe in one of our states or maybe close in our cities, and the end user premise edge that could be, for example, very close to the BTS or the site or the G0B location. So we have like this, let's not say location, provider core, provider edge, and end user premise edge. So based on that, we have like this cloud computing that is essentially based on this enterprise core located here. The fog computer, as you can see here, including some aggregation part located here in this part, in this location. The edge computing, that what is not cloud, let's gonna consider that is just edge computing. The MEC that is covering more or less the same as the edge computing. And also we have this cloud definition that is in particular focused to a building or to a particular site where we can have like a small cloud. But our focus will be in like this cloud computing today, edge computing, and the MEC, multi-access edge computing. So as we saw also from Mr. Raymond, he mentioned a lot about how was this cloud and edge history, about how it was created for some year around 2000. When we talk about MEC, MEC is a multi-access edge computing that is essentially has evolved from 2014 when it was created by the ETSI, by the European Telecommunication Standard Institute, in 2017, where they changed the name to mobile multi-access edge computing. Before it was just called mobile edge computing. And the version we have today, that is release 3 in 2022, is the, let's gonna say, the latest version that we have so far about edge, about multi-access edge computing. So we have like this edge computing is focused on IT and in telco. And the concept of MEC, as indicated here, is essentially an ETSI specification. I mean, from the telecommunication side, but more or less the concept or the concepts defined by MEC and by edge are more or less the same. But anyway, we will see something in the few slides, in the next slides. So when today we're talking about this processing that is not core, that is edge, we can be talking about edge computing or MEC computing. I mean, like 2021 or 2022, maybe if you go to any provider like Red Hat, Ericsson, Huawei, whatever company, most of the company, they mention MEC. But if today, just for curiosity, I mean, you go to one of those pages, and maybe in some of them, for example, in Ericsson or Huawei, you will see still the concept of MEC, as you see here. But most of the companies, for example, in Red Hat, for sure you will see something more focused on the edge computing. Anyway, in the telecommunication side, we can say more or less that edge computing and MEC could be more or less the same, are covering more or less, as you saw, the same area. But the mobile edge computing, as we see here, is defined by ETSI standard. So there is only one standard for MEC. And for traditional edge computing, as mentioned by Mr. Raymond, like in the previous presentation, there is no single set of standards. This mobile, this MEC is specifically designed for mobile networks. This traditional edge computing is for different kind of networks, but let's want to say the origin is the IT, like mentioned by Mr. Raymond before. The location is deployed on the edge mobile network, for example, in the base station. And this traditional edge could be deployed in different locations. There's from customer premise, aggregation point, or different place. So you can have like different kind of application on this, in particular the telecommunication application here. For example, augmented reality, virtual reality, IoT, or whatever application. In this traditional edge computing could be like all kind of industrial application. Providers, mainly the mobile network operators are providing or are using MEC, this edge computing, different organizations, including cloud providers like Red Hat, like AWS, like Google, like Azure, or all of them. They are focused on edge computing. Integration is very close to the network, following the mobile network infrastructure. And this one use different kind of topologies. The data processing is very close to the end user. Here we can say more or less the same. So we can say here the main difference between this mobile edge computer or edge computer is this one, the latency standard. The latency standard defines the MEC. The edge computer, there is no set of standard. Anyway, as we have, I mean, today, you have solutions based on cloud from providers, and those solutions can be implemented or can implement the telecommunication stack over it. So we can have telecommunication application working either over MEC computing, over MEC, or telecommunication working on edge computing. So the thing is, why edge or MEC is necessary for our work? As you see here, when we don't have like edge computer, when we just have this core, we can have like a latency between 70 and 160 milliseconds. I mean, going from the device, the request passing through the base station, going to the core, going to the internet, and then going to the global internet. So here we can have like very long time just to have an answer, for example, to make a click and to ask for a web information. So when we have this edge computer is when we try to put all the computation that we have here in this part very close to the end user as possible. And so that's why we have it like this edge computing, because it's very fast. I mean, it's faster, it's more faster than using the traditional communication that we have before, when we just have the cloud computing. So now with this edge computing, or with the MEC, we can have this processing very, very close to the end user, to have like the 10 or the 30 milliseconds that we require for all of these telecommunication services. Here we have like different kind of application for all of this, because not all the traffic requires the same handling. For example, you have data. I mean, if you have like, take a picture, you don't need like very short time to put it that store like in a database or in your storage area. I mean, you can have here like maybe in seconds, days, hours, or whatever, to store the information here on the core. But there's some critical information, for example, in a company, that because regulations, the information cannot go to the core, but should stay as much close to the end user, to the fabric as possible. Also, because the sovereignty or sovereignty, because, for example, particular data of information that are critical, it's going to say user information, like for example, as you have in the Europe, it cannot go out from the country. So you have to stay to put all of that information, keep that information in your country. So for sovereignty issues, you keep that information close to the country, and so they will not go, I mean, to a cloud that maybe is located in another country. So for this reason, because regulation from the country, or because regulation from the company, because you have like very critical information that can go very far away from the country, or from the office, or from the company, you have the edge computing over there. Also, when you have some application that the processing is easier or cheaper to process locally, as you can see here, that you don't have like a big data center. Maybe you have like a small data center, maybe a rack with all of this cloud computing and all of that. So the energy is very low. Maybe if you put those services in the edge, I mean, in the provider edge, or in the core edge, maybe the energy or the requirement for those services will be bigger. So for those particular issue where you can have like a small server with a cloudified environment, you can have this application also here close to the edge. For critical, like mentioned by Mr. Raymond, for example, for this camera, that you need a very fast reaction. I mean, you cannot wait, let's gonna say seconds, hours, or days to process the information here in the core. You need to process that information from security. Also, in that case, also this edge is necessary. So you can have like this processing very local, even in the camera by itself, like having like some, let's gonna say basic processing here in the camera, or in this center or data center very close to this camera, let's gonna say in an office or something like that to process the data. So in that case, the edge is necessary. There are critical situations, for example, for autonomous vehicles, where you have, for example, like a lot of sensors and all of that. And if that autonomous vehicles is moving and they have like this child, for example, staying here, for sure you need like a very fast reaction. I mean, you cannot wait until all of this information from all of these sensors go here to the core and then go back here. So for that case also, it's necessary to have like this processing even in the car, or also here in this edge, let's want to say in this edge center. So we have like this edge processing capabilities in this vehicle here, and also in this place. So you can have like very fast decision taken here, or if for something that can take a little bit more time, you can process that information here that is still on the edge. So you have this equipment edge, this premise edge, and this provider edge. And in all of those places, you can process information. But for particular this vehicle, autonomous vehicles, you process that information here directly in the car to stop the car as fast as possible. Also for applications, like for example, when you have this IoT and you connect all of those, all of that information in this access point, or this access point, also here is possible to have some particular processing, maybe with some AI application or something like that built here in this model to take some decisions, some basic processing here in this CPE, and also have some other processing here in the data center, for example. But for example, here you have like, for example, if you have like very small data sets of, for example, faces or whatever, you can take the decision here. But if you need more processing, you can take the processing here in this premise edge located here. And also for this augmented reality or virtual reality, also the edge is very useful, because as mentioned in all of those previous cases, you can have like this processing here in the edge. So we have like these very different cases that goes from privacy, security, power consumption, time decision, or IoT, or augmented reality or virtual reality, that can take advantage of all of these edge processing capabilities here in the network. So when we have like this, edge can be used. It's very useful for 5G, because you have, like we saw before, like different kind of applications that can be combined. It's also energy efficient and sustainability. Can also have this enhance, or you can take advantage of the bandwidth, because you don't need to have like a very big backhaul from the end user to the core, but you can have all of that processing in very close to the end user. So you have an optimized bandwidth. IoT, because you can process that also, you can process IoT locally. And if you need more processing capabilities or power, you go to the edge premise, or you can go to the core. The integration is very, let's want to say, easy, because you can have the extension of what you have right now with the cloud and move that capability of processing to the edge. And also you have this very important point, that is the ultra low latency for all of those critical or important processing that you need that you need to process very far, like for example from a camera, for security, for sensors and all of that, that you need to have like a very fast answer. So for that, 5G and edge are very necessary. So here is just to show you, it's not for you to learn all of these functions that we have in 5G core and run, but it's to show you a little bit. Let me just here. Whatever. So we have like these different functions in the core, as you can see, like in the network, you have this control plane function that we have in the 5G core. We have this user plane functionality, like for example, user plane functionalities here. So the main concept from this that I want you to take is in the core, we have different functions that are deployed in the cloud. Also, we have this access or BTS or G-Node functions that we can have for our sites. We have our data network. So we have this BTS connected to the core and connected to the data networks. And most of the functions you can deploy it in the cloud. So we have all of that functions, as we can see here on the left, that we can deploy it on the network. And also we have this edge or multi-access edge computing also defined on the cloud. So this one is just like a general system architecture for the MEC. Anyway, this definition about this MEC, when we have this orchestration or when we have this platform manager, MEC platform on virtualization infrastructure and all of that, is more or less the same concepts are used for MEC and also are using for the edge computing, because in all of them, you deployed the solution on the cloud. I mean, for the MEC, you deploy that in the MEC cloud, and for the edge, you deploy that in the edge cloud. But the main concept is, I mean, the main concept to deploy it is the same. I mean, you need an orchestrator to manage all the connection of all the functions. You need the platform, I mean, with all of these hardware capabilities to store and to process information. You have the manager to deploy it or to define, to use all of those network functions. We need this infrastructure virtualization, I mean, to deploy in the cloud all of these network functions. So with this slide is to show you like how is the deployment of a 5G network in a cloud for core, including the BTS part, the deployment of the MEC or the edge also in the core. So when we deployed like this MEC or this edge in a 5G network, what essentially we have is most of the functionalities of the 5G core are deployed in the core, let's say in the core cloud, and then just the particular functions, for example, these user plane functionalities that we saw from the core, we can deploy it in this MEC system or in the edge solution. So it's possible to connect our RAN solution to the user plane functionalities and to the cloud using this MEC deployment. So there are several possibilities to deploy the MEC or the edge. I mean, what I want to remind here is whatever things that we say here for the MEC, we can also use it for the edge computing. So all of these capabilities for the MEC or for the edge that we have here with these user plane functionalities from the 5G core can be deployed here in the local site, in the local place for where we have our BTS. I mean, in this BTS, maybe we just have like this rack where we have these main functionalities, and with using these cloudified principles, we define these functionalities for the, I mean, to deploy this cloud here with MEC functionalities, including the user plane functions here in this server. Also, another possibility is to use these MEC functionalities with the user plane functionalities here in the transmission node, for example, close where we have like our microwave link. Another possibility is to have it here in this aggregation point. I mean, every time you see this user plane, remember that this is a 5G core that allows us the connection to the data network. And also it's possible to put these functions, these MEC or edge functionalities close in the cloud. Anyway, as defined by the Etsy MEC specification, you have these 4 basic deployment options. Anyway, even if the operator today is not using the MEC as definition, they're using the MEC like principle, like to put in like processing capabilities of the telecommunication functions close to the site, close to the transmission, to the aggregation, or maybe close to the core, as we can see here in these slides. We have seen this deployment in the other deployment, but anyway, here is like a more graphic about how we are putting all of this, where you can see here all of this definition of functionalities for 5G core, 5G core and also 4G core. Here is you see here the HSS is from 5G core. Here you have this MEC server, and so here you have some specific functionality, like for example, user plane functionalities here. And so you have this smart home function or application or IoT application where you have all of this. And most of these applications can be processed here in the MEC server. Also with the autonomous vehicles, with all of those sensors. Some of those sensors can be processed, let's want to say here in the main server, I mean, in the vehicle server here inside this main computer capabilities in the car, or also in the MEC server. Also for industrial internet, for virtual reality, augmented reality, or mixed reality, or whatever. And also healthcare, processing all of that information here in the MEC. So there will be some processing that could be very local at the user or used here in the MEC server. So also when you have retail, let's gonna say manufacture here, energy or smart city, also they can take advantage of this MEC processing. Also, as you remember from the previous slide, here we have this user plane functionalities located here in this MEC server. Also for smart farming, that is also possible to process all of that here in the server. So what I want to show you here is possible to process all of that information either on the cloud, on the main mobile core network, or in the MEC server or edge server located more closer to the end user. So it's not something like very. So here is to show you like the main possibilities, talking about, let's want to say, servers and cloud with cloud functionalities that can be deployed like in several places around our network, very close to the site or close to the mobile core, where we can deploy all of these functionalities to allow us to use all of these functions or all of these applications in the sites. Here is to show you, like for example, how these two operators have deployed all of these cloud functionalities. For example, this Rakuten, as you know, from Japan, they were having like, they were considering like this solution using the traditional remote using or RF unit proprietary. These functions here of DU, CU, user plane, and MEC here located in the edge cloud, and some functionalities here. So using all of these virtualization functionalities, that what they were thinking about how to use it using the all mobile network operator definition, with this Rakuten, they decide to define all of this or to take advantage of all of these virtualization networks. So having this edge cloud this definition of the Rakuten cloud, even for central cloud or edge cloud or regional cloud, to deploy all of these functionalities all around different places. So they keep in the central cloud, like the main 5G core functionalities. They put it in this regional cloud, this MEC with user plane functionalities in this code server. And in the edge, you put in this DU, CU using this principle, these Open RAN principles, and have this 5G RF unit in the different places around Japan. So here, I think this Rakuten is a very good example of how they deployed this cloud and edge cloud using the Rakuten cloud, the proprietary Rakuten cloud definition. Here in this, we are not using a proprietary cloud from the operator. In this case of Dish USA, we're using like a public AWS provider, what we call hyperscaler, to deploy a traditional mobile network, as we can see here, with different providers, using this virtualization ecosystem, taking advantage of AWS, as you see here. So all of this definition that I don't know if you remember from AWS, where they have this cloud deployment, like in the region, local zone, or outpost solutions that you can have like this from AWS. Taking advantage of all of this, they put these core functionalities from Nokia, as you see here, to put or to define the cloud network using this AWS public cloud. Here, they define in this local zone, they put the user plane functionality from the core, this centralized unit from, let's want to say, Open RAN. And using this let's want to say this Altiostar Mavenir Open RAN BTS, they deployed this central unit here, this distributed unit here, and this RF unit, as you can see here, from Fujitsu and MTI. Anyway, this document is from 2021. Maybe today they have changed something. But these two examples is a way to show you that this edge computer is not just in PowerPoint. It's something that has been defined or has been deployed already by different operators. For example, in the USA, they're using a lot the multi-access edge computing definition. Maybe in Latin America, they have not deployed this concept of multi-access edge computing. But it's something like to show you like how they have been using that is possible to put telecommunication in an edge cloud from public provider like AWS, or from a private provider like Rakuten, as we saw before. So this is a report from the ENNO. ENNO is the European Telecommunication Network Operator. So they have like this report from 2024, and where they mention that for the edge cloud computing, we have like different numbers around the world. I mean, we have so far, for example, in Europe, we have like 4 commercial operators already working with edge computing for telecommunication, and edge that is planned for the very close future. So in general, we have all of these edge cloud offers, what we have for our different regions, Asia until the rest of the world, what is commercial, what will be in the close future, what is in the what will be expected to spend in public edge computing services, as we have here per region. So this is like the latest news that we have so far about edge. As we see, some providers or some operators are working or are still working with these, let's say, MEC concepts. We see here like also April 2024, they are still talking about MEC. Anyway, MEC is not something like a concept that everybody's using. Some operators and some providers are using MEC concepts. Some other providers are just using H definition in the network. But anyways, referring more or less to the same concept. I mean, to what is not cloud. Cloud computing is using Edge, or is using MEC processing. And so here, what is the future of the MEC? So here, as we can see here, the future of Edge is prepared for growth and innovation, particularly for 5G network and for the future 6G. So we have advantage, or we're expecting to have advanced use cases. We have some cost consideration that could help us, or that could help us to make this development using the Edge. Energy efficient and sustainability for future Edge deployments, for enhanced standards and specification like augmented reality or virtual reality that could take advantages of all of this. Integration with 5G and beyond, Edge and AI, that is also a future or present use for all of this Edge and MEC processing. And everywhere network and computing, that we are not just processing information on the core, also we are processing information in the edge, or very edge user. So the final consideration, as you see, multi-access edge computing is an edge definition standard, most focused on mobile networks, mobile network architecture. Cloud and edge are very important components in the evolution for 5G and 6G networks. Also, the MEC. Anyway, the MEC is not something like 100 of the operators are using MEC now. There are some deployment of MEC around the world, but not all of the operators are based on MEC. Some of the operators are using just edge computing. For example, using the processing from Red Hat or from some other providers. Edge and MEC offer advantage in terms of latency, as we saw before, bandwidth and energy efficiency. We can have support of different kind of application, making a critical component of future telecommunication infrastructures. However, there are challenges such as cost and complexity in the network. So maybe the MEC will persist in the following years. Maybe the MEC will be just keep like a concept and maybe used by edge provider or by edge operators. But anyway, the MEC principle will be still used. Here are some links for the ETSI edge multi-access edge and for the 3GPP edge computing that you can check.